All right, guys. So here we start now. First, all of you turn your cameras on. That's the only criteria in the class. Come on, guys, be quick. Turn on, turn all of your cameras on. Uh,
Hello, sir.
all right, Bruno. Yeah, yeah. Tell me.
Sir, can you hear me?
I can, dear. I can.
Yes, sir. Sir, my name is Mohammed Arshad. Right now, I'm in Saudi, sir. I'm fasting, so can I? And now I should break my fast. So, like, can I leave the meeting right now?
Oi, same
Like to leave the
meeting.
meeting?
Come with
Yes,
me.
sir.
Fine.
Because I'm
You see
fasting,
me?
so I should break
Hold
my
up.
fast right now.
Wait.
All
Click
right.
on view all
You have
participants.
first of all, guys.
Like,
Just Harika, you just mute yourself
oh, I recognize them.
and
Hold
see,
up.
Arshad, if
Turn
you
the
have
video
to
off.
go, you can go.
Come.
But if you can turn your camera off and you can stay in the class, that would be better as well. So it's completely on you. If you can stay, then that would be great, guys. But if you have to leave, then I'm not gonna stop you.
Oh, shit. Off.
Sir, I'll be in 15 minutes, sir.
All right, all right.
Okay, sir. Thank you.
Excuse me, sir. I need to rename myself.
Mhm.
I'm using my mom's computer, so
All right, just 1 second. Yeah, you can do that now. And guys, just one thing that I have, just one request. Make sure that you are all muted during the experiment is being done. Right after the experiment is over, I would be giving you time to talk to me and all. But for the time being, guys, keep your mic on mute. There are a lot of noises coming on there. That it would be a little bit difficult for us. And I guess you do know that this entire session is being live streamed on YouTube. So I don't want the entire world to know that what you're talking about at your home, right? All right, sounds great. Now, guys, there is something that we are going to talk about. Just 1 sec. So will it be all right? Yes, Shubhada, no issues with that. Huh. And one more thing, guys, if you really have to leave the session, I won't really stop you from there. But guys, if you can keep your cameras off and stay with me, there are a lot of interesting things we're going to talk about. And do watch the recordings. If you have to leave right now, then do watch the recordings because it's going to be very interesting. All right. How many of you have met me before? Just raise your hand. There are some known names that I can see. All right. Okay. Now let me have a quick tour of the class real quick.
sir, what are
I
you
can,
doing?
dear, I'm gonna talk about that. Before that, guys, I can see that many of you have kept your cameras off. Don't do that. Turn it on, every one of you.
Because there was some other class.
No issues here. We haven't really started. We are going to start right now. All right. Now, lower your hands, guys. So many of us have met. I'm going to give you a short introduction about myself, real quick, guys. I'm a chemistry teacher over here in askIITians, and I've been here near about 3 years. And right now, actually, I'm doing my PhD in chemistry from IIT Bombay. And now, guys, today what I'm going to do is, guys, you can lower your hands, Pranav, Savesh, Rishita. You can lower your hands. See, actually, what I feel is there was one more time when I have been here in the same platform doing the same thing. There was an experimental session that we have been into, and there I have actually shown you a particular live experiment, but due to the lack of time or a lot of questions coming from you, which I appreciate a lot, and I had to, guys, you were fabulous at that class. You have asked really good questions, and for that reason, there were some questions that I had thought about discussing with you, but I couldn't really do that. So, I asked the entire department that I would be performing that one experiment one more time, just to show you one more time, and just to ask you some much deeper questions from there. Okay. So guys, right now the topic that we are going to talk about is actually related to solubility, or you can say solution. I guess we know all of us, we do have an idea about what's a solution, right? When a solute and a solvent are mixed together, we call it a solution. Now, there's a very simple question that I can ask you from here. The question is, let's say I'm mixing two liquids, A and B, together. Now, if I ask you which one is solute and which one is solvent, the thing become a little bit difficult. But guys, always remember the one which is more in amount, that is always solvent. All right. And the one which is less in amount, that is solute. So what I am going to talk about is, it's a little bit a discussion that I'm going to talk about. It's a little bit of a higher chemistry. This concepts that we are going to discuss, Abhiram, mute yourself. The concept that we are going to discuss, that we need in class 10th, then we need in class 11th, we need in class 8th and 9th as well. And guys, if you are preparing for any kind of competitive exams, this particular topic is going to be the heart of that exam. Yes, yeah, no issues with that. Definitely. Oh, all right, Pranavi. You're Harshini's sister. Nice to meet you. All
Yes,
right,
sir.
now, guys. All right. So the thing that I was talking about is about solubility is something that we're going to talk about. Okay. So without wasting any more time, guys, I'm going to turn off my camera here. I'm going to move into my another device. From there, I'm going to turn on my camera. And from there, I'm going to show you the entire experiment first. Then I'm going to discuss about the entire topic. All right. So hang on for a minute. I'll be joining through the other device, and then I'll be showing you the experiment, guys. That would take near about 30 to 40 seconds. Okay. So hang on there and just excuse me for 40 to 30 to 40 seconds. All right. I'm coming. All right, guys. So I have joined through the other device. You won't be able to see me for the time when I would be doing the experiment. And just give me 1 second. I'm gonna pin myself from that device. Just find that real quick. I lost switches were joined, so it's a little difficult for me to find where I am actually. Just 1 second. Ah, yes. So guys, I think you can see my setup real quick, and this is a very simple setup that I have made over here. Yeah, you can see it, right? And this
Yes,
is
sir.
kind of a revision to most of you, actually, those who have been in that session. So guys, what I'm gonna do is right now you can see that this is something that we can do in a live class, and definitely, guys, you can do it at your home as well. It's not really a difficult thing to do. Just little more clarity is what I need, guys. Just give me a sec. Guess it would do. Okay, let's try it. We can from here. Okay, so guys, like I said, this concept is completely based on solubility. Now, solubility is actually a topic where we understand not every substance is soluble in everything. There are certain substances, those who are known as organic substances, those who are dissolved in organic solvents. And there are certain substances, those who are known as inorganic substances, they get dissolved in inorganic solvents. So I'm going to show you what I mean right now. Okay. So first, what I'm going to do is I'm going to take some white powder and I'm going to put it in that beaker. You can see that plenty of them. All right. Now, what we're going to do is it's not really that clear, isn't it? Yeah. Now, what I'm going to do is I'm going to add a particular substance. I'm going to talk about what is this white powder, what is this thing. But right now, I'm going to do is I'm going to add some liquids on it. So let's add it. Okay, so this is the particular liquid that I have added on this white powder. Okay, and again, guys, I'm not going to disclose the entire thing right now. I'm going to talk about this in details right after the experiment is over. So for the time being, just look into it. Now, what I'm going to do is I have a colored solution in my hand right now. I'm just trying to make a little bit more, but I need a little more than what I have right now. So I have a red colored solution in my hand right now, guys, which I'm going to pour in this mixture that I have. And let's see what happens right after. So I'm adding a red colored mixture very slowly. A little bit more. All right. A little more. Side. Okay. Let's have a look, guys. This is a very popular and very famous thing in YouTube. We call it a lava lamp, isn't it? But guys, they are definitely showing you the experiment but they are not really discussing about the entire chemistry behind it. That is what we are going to do here, guys, so that later on in the higher classes, we do not have to struggle about solubility and the solvation anymore. So guys, have a look in this entire texture. It's beautiful, isn't it? So you can see that there is some sort of red colored substances are falling from the top and they're again just going up right after this. So what would happen if I just add a little bit more? See, more. All right. The point is, more I add, this texture is increasing, isn't it? So guys, write it down in the chat if you have ever seen this thing before. Anywhere. Like not in my sessions though, I have definitely performed this before. Not in my sessions, other than my session, if you have ever seen it. It's beautiful, isn't it? Guys.
Sir, I didn't get what that red thing was.
I'm definitely gonna disclose about every single thing, guys. Right now, just enjoy the texture and make sure whenever I'll be discussing about this, guys, you won't be seeing this thing anymore. So make sure whatever you see right now, you can remember what's really happening. Look into every single details, guys. Like how the things are falling into the ground, how the things are going up in the top side of the entire solution. The entire thing is actually important for our discussion right now. This is actually, if you just search in the YouTube as by the name of lava lamp, you'll be able to see it. And guys, right now, we are going to discuss what was it. And after that, I'm going to show you the entire chemistry behind this. So first, I can see that many of you have turned your cameras off, guys. If you can turn it on. The point is, first of all,
So why is this like red stuff going down and then again coming up?
I'm going to answer all the questions. First of all, what was the white stuff that I have given in there? I'm going to do one thing that I've never done actually. If I disturb this, what would happen? Little. So guys, when we mix something like that, they actually get dissolved with each other, isn't it? Are they going to do that here? Let's see. Nothing really happens, isn't it? So actually, you know what what is this? This white colored substances that I have kept at first, this was actually baking soda. You have definitely heard about baking soda before. And right on the top of that, guys, the liquid that I have poured, which was colorless, that was a vegetable oil. So just a normal vegetable oil that you can find in your kitchen. And right after that, the colored substance that I have put in there, guys, the colored solution, the red color one, which actually facilitated the entire reaction. Let me show you one more time. This thing, this red colored guy, this is actually a vinegar solution. A vinegar which is having a little bit of color in it, and you can just give us some sort of food colorings on it, and it's even beautiful now, isn't it, guys? So this is the ingredients, guys. So one more time, the white ingredient was nothing but baking soda. And then after that, I have put some vegetable oil. And then, guys, you need a little bit of vegetable oils to get this, texture on it. And then, guys, you just need to give some some vinegar. And in there, guys, you just have to make some sort of food coloring. I love red. That is why I have kept a red color texture over here, guys. If you love green or a blue or yellow, you can give that kind of food coloring. All right.
We can
So
even do multicolored, right?
yes, I would love to see you guys doing that and send me the video. All right, you can just definitely.
What is the red substance?
Red substance is nothing but vinegar. It's a vinegar
Can you
with.
repeat all of that you said, because sometimes your voice was glitchy.
Mhm. My voice is glitching, guys. Is it happening for all of you?
Little bit.
No, sir.
No, sir.
All right. Don't worry, guys. I'm gonna write it down. I'm going to explain this entire thing for you. This is just the visual thing. Then now the entire chemistry part is yet to be discussed. I'm gonna write the entire ingredients, and then I'm gonna discuss what's really going on in here. All right, guys. So I'm closing this camera and I'm going back to my original position to discuss about the entire chemistry behind it. And like I said, guys, this particular chemistry that I'm gonna discuss with you today, if you can remember this, you need it till class 12. In class 12, there would be a chapter called solution. If you just search it up, look it up right now in class 12 in CRT, you'd be able to find a chapter called solution, guys. You would be discussing about this concept even over there. So you can understand, guys, how important this particular topic that we have discussed is. So let's get started with the. I'm very sorry for the noise. Let's get started with the entire explanation part, guys. So let's unpin that device now. Guys, just tell me one thing. I'm going to share my screen with you. Just tell me whether you can see it or not. The last time when I have discussed about this particular experiment, I've done this experiment the last time, I couldn't really tell you the entire, chemistry behind this, which is I'm going to discuss today. So one second. Anytime you send a question to me, guys, send it in the host account always. All right.
Okay, sir.
All right. I guess you can see me now, and you can see the screen as well, guys. Quickly tell me. Can you see my screen?
It's loading.
Sir, it's
Loading. It's
Not
loading,
yet.
sir.
All right. You will be able to see it. Hang on with me.
Yeah.
Sir, now it is visible.
Yes, sir.
Yes, sir.
It's visible, right, guys? All
Yes,
right.
sir.
So,
Yes, sir.
all right, yeah. Just make it black because it won't hurt your eyes then. Guys, whenever I'll be writing something now, I'll be looking at that side. I have another screen in there, right? So before I get started, how many of you like chemistry? Some of you I do know, but for those I do not, know about?
Sir, I don't like chemistry. I love chemistry.
That was deep. Bhavya, from when you started liking chemistry? You are not in the list before. Right, you?
Yes, sir, I thought you knew.
Uh-huh. Come again?
Sir, I thought you knew I like chemistry.
Oh, I didn't actually. Is it because I am a chemistry teacher and I'm here in the class because of that? You are raising your hand?
No, sir, not really.
All right. All right, guys. So right now I have how many hands raised? Let me see. 39 in a class of 100, like I expected. Okay, guys. Now you have to lower your hands. 43 now. It was increasing, by the way. All right, guys. Lower your hands now. Lower your hands. Now let me tell you the entire chemistry behind it. First of all, the ingredients that I have used in there. The first ingredient that I have used in there, guys, was first I have taken a normal. You can take a normal glass or a beaker would give it a better texture. Then on that, what you have to do is you have to give some baking soda. Guys, if you go into the market, they might ask you, the shopkeeper might ask you that do you need baking powder or baking soda? You would be choosing baking soda at that time, not powder. All right, baking soda is what I need. What's the difference between them? I'm definitely going to talk about that as well. Right after that, guys, I have mixed. Right after that, I have mixed a little bit yellowish substance on it, which is nothing but a vegetable oil. Okay, you can use any kind of oil, guys. The moment I tell you the chemistry behind it, you'd be able to understand the type of oil doesn't really matter. Then what I did is I have added some vinegar. I guess, guys, you know that vinegar is something that we use to cook. So you can just find all this thing in a normal market, in a normal store. The moment I added the vinegar on it, what actually I saw is it become, I made it red, by the way, to give it some sort of, reddish color on it. And then we saw that lava lamp going, starting to happen. All right. Okay, Prachi, sir, can we use water instead of vinegar? We can't. We can't, Prachi. All right. See, all the questions that you have, just give me 15 more minutes. Everything would be cleared. Okay, on your hand. So the topic that I'd be discussing doesn't really matter which class you are in. Okay, you'd be learning something new. First of all, let's understand the chemistry in here. And I want all of you to turn on your camera, guys. Don't make me say this over and over again. So the first thing is baking soda. So those who are in 8 and above, they know that baking soda is a chemical substance who has a formula of, can we use lemon juice instead of vinegar? We can, Akshay. We can. NaHSO4. This is baking soda. Is that correct?
Yes, sir.
Yes, sir.
It is correct, everyone. So NaHSO4 is a correct formula of baking soda. Now, right, guys?
Sir, it's not right.
I do want to know
It's-
from you.
Sorry, sir.
I do want to know from you guys. I have written something. Is it correct?
Sir, it's NaHCO3, right?
Okay. Who was that, by the way?
Soham Joshi.
Soham. Very good, Soham. So, guys, pay attention. This is something that I want from the higher classes. Okay, you guys should know this, isn't it? NaHCO3, sodium bicarbonate. What do we call it? Sodium bicarbonate, or sodium hydrogen carbon. Hydrogen carbon. This is what known as baking soda. All right. Now, if they ask you, would baking powder do? No, baking powder won't do. Because, guys, baking powder means when you add tartaric acid, or sodium potassium tartarate, it's a very complicated name. Just there is a molecule called, there is an acid called tartaric acid. When you add in NaHCO3, that together, they call it baking powder. So, guys, I don't need baking powder. I need straightforward this chemical substance, which is known as baking soda. I just need NaHCO3 in here. Okay. Now, on that, what I did is,
So if we use baking powder in this experiment, how would it affect it?
You are going to get the answer right now. So we would be using, guys, just stay with me for 15 minutes. I'm going to answer all the questions that you have in your head. I'm not going to answer, actually, it would be answered on its own. So over here, Ananya, what we do is we take this and then we add some vegetable oil on it. So guys, I'm going to give you all the chemical composition of everything right now. Do we know what is an oil? What is the chemical composition of an oil? Do we know this, guys? Irrespective of what is the oil, like, doesn't matter, guys. It can be diesel, it can be petrol, it can be any oil out there. But what is the chemical composition of an oil? Do we know this?
C, right? Carbon.
Who was that? Guys, just raise your hand before you say something, so that I can, recognize you. So,
So,
carbon, only carbon.
sir, I think so.
All
Maybe
right.
wrong.
No, you are very close to the answer. Yes.
Sir,
Go
I
on.
feel it's hydrocarbon.
Hydrocarbon. Okay, that is correct. You can lower your hands, guys. See what is an oil. How does it look like? You know, there are carbon atoms, those who are connected with each other. Do we know, guys, carbon atoms do get connected with each other in this way? They make a long chain. For those who are in the junior classes right now, let me tell you, this is how our body is formed as well. Have we heard about DNAs, RNAs inside our body, guys? We do know that there are DNAs and RNAs. There are amino acids inside our body. Everything is actually made up of this carbon chain. And do you know what we call it? We call it catenation property, right? Carbons joining together. So guys, carbon atoms, they can join together and they can make big chains. I'm going to show you right now, guys. So focus in the video right now. How does it look like, the carbon chains? Okay, I'm going to spotlight my video for the time. Okay, have a look now. You can see me, guys, everyone. So I have a carbon atom. If I add another carbon atom with it, with a bond, you can see that. This. Then if I add one more carbon atom with it, this. If I add one more carbon atom with it, so guys, we can just do this the entire day. You know, this is how diamond is being formed. This is how, guys, don't do this. Don't write it in the screen. Now, have a look. So guys, this is how we can just entirely keep on adding them up and we can make a long carbon chain. So guys, do you see what is the difference between the diagram that I have drawn and the thing that I'm showing you, the structure that I'm showing you? What is the difference, guys? Have you spotted it?
Sir, the thing that you
But on
do
the
is,
screen, it's completely linear.
this is in this is not straight, this is bent.
Exactly. Guys, this is a learning curve for you. Right now, if any teacher draw a carbon chain for you, they will be drawing it linearly. But always remember, guys, carbon never joins linearly. It's a zigzag form. If I just keep on adding them now, I have to add them like this only. So it's a zigzag form structure. Always remember this. All right. So this is how, yes, Soham, you have a question for me?
So that's because carbon is like 6 atoms outside, right?
Not because of that here. Carbon have a specific structure, which is called tetrahedral structure. So there is called something called hybridization. All these things actually you would learn in class 11. So guys, it just looks like a zigzag. So right now, you can look into the screen one more time now. So this CCCC, this chain, and some hydrogens with it. This is what actually the chemical formula of the oils. And guys, you can make it as long, as big as you want. Okay. Just keep on doing that and you would be getting the formula of oil. You know, the petrol that we put in our vehicles, they are actually having 10 carbons in them. The gas ovens, the cylinder that you have, LPG cylinders, you know, they have 3 carbon system, 4 carbon system, and 2 carbon systems. So there are 3 types of systems in there. Just a sec. So there are 3 carbon type of chains in there, guys, which is 3 carbon chain, 4 carbon chain, and 2 carbon chain. Like, let me just show you one. How would the 3 carbon chain look like? So guys, the LPG cylinder that you have, in your kitchen, this actually looks like this molecule, that gas that you have in there. So guys, all the inflammable substance that we use to run our vehicles or to cook, they are all hydrocarbons. Guys, why do we call it hydrocarbon? Have a look. It is made up by hydrogen and carbon. Simple. It's called hydrocarbons. Are we understanding everything that I'm talking about, guys?
Yes, sir.
This
Yes.
class isn't becoming that difficult, right? If it is becoming difficult, then do let me know. I would make it a little bit simpler for you. But guys, I am actually, doing this in a kind of way that you don't have any doubts in your head anymore, for whatever grade you are from. So what actually happens is, this is oil and this is vinegar. This is baking soda. Now only one thing is left, which is vinegar. I didn't really told you what is vinegar. So is there anybody who can tell me what is the composition, chemical composition of vinegar? What is vinegar made up of? Yes, Savish? Guys, you can write it in the chat as well if you want to answer this. Yes, Savish, go on.
Sir, vinegar is made out of acetic acid or CH3COOH.
Very good, guys. That's correct. I can see the chat as well. All of you are correct. Trisha, Savish, very good. All of you are right in the chat, guys. Well done, guys. I want you to be a little bit active in the chat. Talk to me. Don't just stay there. Don't just listen to this. Talk to me. Then I get to know that how interactive you are, how much involved you are. All right. So, guys, what actually happens is we get vinegar, which has a chemical formula as CH3COOH. This is also known as acetic acid. Right, Mike? Right. So this is called acetic acid. So these are all the components that I have written for you. Now, let's come to the concept of solubility. What was really happening in there? So guys, pay attention now. This is the major part. To begin with, guys, for solubility, I'd be starting from the basic level for the lower grades. Then I'll be taking it all the way to the higher grades. Okay, the concept would be going like that. First of all, guys, to understand about solubility, you need to understand in chemistry, we have two types of substances. So guys, there are two types of substances in chemistry. Make sure, guys, you are on mute. I guess, Kushagra, your mic is on. Let me just have a quick view of the entire class. If everyone is turning their camera on. All right. Now have a look here. So, Sanjay, Arshad, what's going to happen? There are two types of substances out there in chemistry. One of them, Pranavi, we call it organic substances. And the other one is, Arya, inorganic substance. Very good, sir. Now, what are the organic substances? So, actually, the things that we find in the organs, they are called organic substances. Can we name some, guys? Can we name some in the chat? Anything that we find from the organs, right, Mahi? Okay, I'm gonna take your answer, but guys, think about it. In class 7 or 6, you have heard about this. What do we find inside the bee stings? What do we find inside the apple? Very good. Lactic acid, malic acid. Then what all do we have, guys? Tartaric acid. Remember these things? We learned it. Oxalic acid. Very good. Citric acid. Right, guys? We have heard about all these names before as well. Potassium definitely better. But we need to understand here when we talk about organic substances, they are secreted from the organs. It's not only they are found in the organ, they are secreted from the organs. Potassium is not something that is secreted in the organ. So potassium is not going to be the answer.
So what about HCl?
HCl is not again going to be secreted from our body, right? It's there, but it's not secreted. So HCl is also not an organic substance. So guys, all the things that we find in the organs, like citric acid, oxalic acid, like we can just spend the entire eve by writing them, and definitely malic acid, tartaric acid, whatnot. Then this molecule, the vinegar, that is also found in our body, guys. That is our acetic acid, lactic acid. Very good, Sankal. So any which ways, you do got the point, guys. These are the things those are actually called organic substances. And what are the inorganic substances? Those are not really found in our body, but we can make them in the lab. So inorganic substances are all the HCl, HNO3, H2SO4, every single thing. Carbon dioxide, methane, every single thing.
Ammonia.
Yeah.
Yes, ammonia can also be there. But in which case, guys, these are the two types of substances that we have in our hand. All right. Now, are we all clear up to this, guys? Is it becoming very difficult for us to understand? No, right?
No,
So
sir.
far, yes, we are doing good. So I'm going to take it a little bit higher in level. I guess we'll be fine with that. Now, there goes a statement, which goes like dissolves like. Whatever you'd be learning today, guys, let me tell you, this would be helpful for you till class 12. So do make a note of it. All right. So Shubhada over here, like dissolves like is the statement that we need to know. What do I mean by that? So Sankalp, if I have an organic substance, where would they get dissolved, guys? Organic substances. Very good.
Inorganic.
They would get dissolved in organic substances only. Would get dissolved in organic substance. So could you read the inorganic substance? Yes, I'm gonna do in organic substance. So guys, like dissolves like. Organic substances would get dissolved in organic substances only. Okay. Similarly, if I have an inorganic substance, that would get dissolved in an inorganic substance. Why does water not dissolve salts like carbonate, lead, chloride? Pranav, I am right now giving the answer to your questions, right?
Okay, sir.
Okay. So that means, guys, if I take an organic substance, so now when I'm trying to make a solution, so solution contains, solution contains a solute and a solvent. Right? So Prisha over here, Pranav, if my solute is organic, tell me now, what kind of solvent do I need?
Organic.
Everyone? Organic, right? So Vijisha, we need organic solvent. If I have an inorganic substance, what kind of solvent do I need? Inorganic.
Inorganic.
That means now, guys, I want you to think about this now. If I take sodium chloride, it is an inorganic substance. We can make it in the lab. How can we make it? If we take NaOH, sodium hydroxide, and if we react with HCl, we get it. Okay, Sveta? So Kushagra, if I add HCl and NaOH, I can find Tavish, I can find NaCl. So NaCl is an inorganic substance. Right or wrong? So now, if I take NaCl, where would I be able to dissolve it? Something which is inorganic, which is water. So guys, water is an inorganic substance. That's why it dissolves inorganic substance. The moment I am trying to dissolve oil, which is an organic substance. Oil is an organic substance. So guys, would oil get dissolved in water?
No, sir.
No, sir.
No. We have seen this plenty of time, guys. Oil doesn't dissolve in water. This is the reason why. All clear? Right?
Yes,
so oil doesn't dissolve in water. So
Sir, can you repeat, please?
definitely one more time, guys. Listen to this. NaCl is our salt that get dissolved in water because water is an inorganic solvent. But if I talk about oil, guys, oil is an organic solvent. See, organic substance. See, the organic and the inorganic definition is much more clarified in class 10th carbon and its compounds chapter. So if you want to know about organic and inorganic substance more in details, guys, just go to class 10th NCERT. all you have to do is you have to open up the NCERT and go to the carbon and its compounds chapter all the way to the end, and you would see that they are clearly telling you what is an organic substance, what's an inorganic substance. As our time is a little bit limited over here, guys, that's why I cannot go deeper down about it. But all I'm giving you is, let's say you have 5 minutes in your hand. What all things can you search about in chemistry? What all things can you try to know in chemistry, rather than watching some normal videos, watching some videos like why is sky blue? Rather than doing those things, search about this. What's an organic substance? What's an inorganic substance? That kind of things. All right. Now, all right. Okay, guys. So here, Priyanka, the point is, oil is being an organic substance. It doesn't dissolve in water. Now, what I have used in this entire experiment, Ananya, I have used baking soda, NaCO3. I have used oil. I have used vinegar, which is carboxylic acid. Okay. What else? Have I used anything else, guys? No. This was the white powder that I have given. Oil was the that yellowish color substance that I have given right after this, and this carboxylic acid is the thing that is the vinegar with a red color that I have given. So actually, what happens is,
So what did you call it?
vinegar, carboxylic acid.
So
Oh,
carboxylic acid.
Oh yes, you can call it acetic acid, but it comes in the group of carboxylic acid. This is something I shouldn't be using. Acetic acid would do. All right.
Okay.
So Safreen, so Anishka, now the point comes, what would happen when I mix them together? See, the oil being an organic substance. So what are the organic substances over here, guys? This is an organic substance.
Oil is an organic.
Oil is an baking soda, it's an inorganic substance. So guys, have you noticed that when I have given baking soda and oil together, they were not mixing with each other? Even after when I dissolved it, I showed you, right? I disturbed it and they were not getting dissolved.
Yes, sir.
Exactly. So because of that, actually, Dviti, they were not really getting dissolved. Right? So even if you try your best, guys, they are never going to get dissolved because this is inorganic, that one is organic.
Sir, in that sense, if we use baking powder, since it is containing tartaric acid, it would dissolve, is it?
If I use baking powder, then just give me 2 more minutes. I'm going to tell you what would happen. Okay?
Okay, sir.
Right after this. That was a good question that you asked me. Now,
Excuse me,
guys,
sir.
yes. Go on.
May I leave? I have dance class in a few minutes.
All right, Anya, definitely you can leave, but do watch the recording. All right.
Okay. Thank you, sir.
You're welcome here. Guys, keep your cameras on. Now, like I was saying over here, Pranav. So, the moment I have given the carboxylic acid, means our vinegar with a little bit of red color, what actually happened is the carboxylic acid, it went and came in the contact of my bicarbonate, means my vinegar. Now, you know what actually happens if they come in contact with each other, Rishvi? See, this is going to happen. This definitely neutralization. But actually, that happens is they release carbon dioxide in this reaction.
Yeah.
Okay, you knew it. Let me show you how. Baking soda, HC, where have we used this before? During making of cakes, biscuits, right?
Yes,
Bharat?
in bakery.
Right, Sankar?
In bakery.
Why do we use the baking soda over there, guys? To make the cake fluffy?
To make it fluffy.
Exactly, HC. So to make it fluffy. So how is it becoming fluffy, guys? Because the carbon dioxide is what getting released over there. Exactly. So the carbon dioxide is actually making it fluffy from the inside. Right, Savesh? Right, Kirti?
Yes,
So this is what actually happening in their Prisha. So because of that, we know that this baking soda, Krishna, it is actually a source of carbon dioxide in there. Now, I guess, Prachi, you can understand, Lasha, you can understand, what were those bubbles coming up? What were they? They were carbon dioxide, isn't it? There were some bubbles coming up. Have you noticed that?
Yes, sir.
They were all carbon dioxide bubbles. But this carbon dioxide, the moment it went up and then it came down, because it is a gas. So gases are very, very random, right, guys? Gases are not really like us. They don't sit in front of the camera. They are like just the people, those who are keeping their cameras off, guys. It's just like very unstable. The gases are very unstable. You cannot really keep it in one place. They are just running away here and there. Why does that happen? Is there anybody who can tell me? Why are the gases so random, so powerful?
So because they have spaces between them.
They have a lot of
So their particles have high
something like
kinetic
kinetic
energy.
energy.
Have a
They
high
exert
amount of
Right.
pressure.
kinetic
I,
energy.
density.
I got an answer. I got an answer. Guys, just raise your hand who said they have a lot of kinetic energy. Who was that? Lasha. Very good, Lasha. The answer was correct. Very good, Akshay. The answer was correct. Safri, the answer was correct. They have a lot of kinetic energy. What is the kinetic energy? The energy that kept you going right now. Right? You are just running here. If I just right now ask you, close your camera and go play whatever you want to play. You will start running it here and there, right? That is called kinetic energy, guys. Kinetic energy is actually a huge topic to discuss about, to talk about. But any which ways, guys, for the time being, kinetic energy is the energy that we have within us, which is giving us the energy to move from here and there. So, Bhavya, what actually happens is over here is the gases, as they have carbon dioxide, as they have a lot of kinetic energy, they were actually moving here and there, Lasha. And as a result, guys, you are seeing that kind of a dancing of the bubbles. Right, Shubhash? Right. So, guys, that was the entire chemistry behind it. So, what have we learned entirely so far from this experiment and from the discussion? The first thing that you need to remember, guys, is this statement, the topmost important statement of this session. Like dissolves like. Every organic substances would get dissolved in organic substances. Every inorganic substances would get dissolved in inorganic substances. So guys, if anything is getting dissolved in water, do remember that that's an inorganic substance. Okay, we have a bonus knowledge right after this. Okay, a bonus point that I'm going to talk about. Okay, the basics first. So like dissolves like. So what actually happens is organic substance gets dissolved in organic and inorganic gets dissolved in. What is an organic substance? What's an inorganic substance? That's the second important topic that we have discussed about, guys. There are certain things that we can reproduce or we can generate from within ourselves, from the organs. They are called organic substances. Those who are actually formed in the lab, they are called inorganic substances. But guys, I'm just scratching the surface right now. This is just the tip of the iceberg. Organic chemistry, inorganic chemistry is a topic of class 10th, 11th, and 12th. So I am a little bit, constraining myself, refraining myself from telling you about them in details. But this is all about it. Then what actually happened is, guys, I told you about the solubility and how I used this particular phenomenon of solubility to show you that beautiful texture and the lava lamp kind of a thing. Now,
Yes, sir.
the last add-on
Sir,
point.
I have a doubt, sir.
Go on.
Sir, how is oil organic and water inorganic?
How is oil organic and water inorganic? Like I said here, there are two definitions of organic and inorganic. One is, which is secreted, that is something that I told you. The thing that I'm actually stopping myself to tell you, and as you asked me the question, I have to tell you now. Organic substances are the substances, those who are made up of carbon, hydrogen, oxygen, and nitrogen. These moieties. We have these moieties in organic substances. All right. Oil is an organic substance because it was a hydrocarbon, right, David? Right, Diti?
Yes,
it
sir.
had a hydrocarbon.
Sir, is it
Okay,
organic
sir.
if it has one of these and something else also?
Yes, sir,
There
but
are
carbon
five-
dioxide is inorganic.
There are five. No. There are five exceptions to this, guys. See, I don't want to go there. Actually, this is a huge topic to discuss. It's a huge topic to discuss. I have to just show you the tip of the iceberg, like I said. It's a huge topic, guys, where I have to give you the exceptions. Why are they organic? And how can we distinguish them? And all the definition, do they really work in this way that we can just segregate them that easily? It's not like that, guys. Okay. Let me tell you the last point first and see if that clears out a little bit of your doubts or not. Okay. The last point and the bonus point of this session, guys, then I'll be taking your doubts for the next 7 minutes. The bonus point is water is an inorganic substance. So it should dissolve it should dissolve inorganic species. Right, Sugit? Right, Pranav? Drupal? Clear? It should dissolve inorganic species. Now, water, it is a little special for us. So it is actually, but water has H and O in it. But no carbon in it, na dear? You need carbon to begin with for organic substance. Okay, Nishka? Right, Kavya? Now, over here, Joan, water is a little special chemical substance, which is also known as universal solvent. This is only seen in water, guys. And do you know what I mean right now by writing it as universal solvent? If you feel this is difficult, guys, you can not remember it. That would do. Okay. So universal solvent means it can dissolve organic compound
And inorganic.
and inorganic compound. Means mainly it would be dissolving inorganic compound, but it would be dissolving some organic compound as well. Example is glucose. Guys, have you ever had glucon D right after you had a tough game or something? You had it, right? So, Raksha, we know that, Aya, we know that glucose is something that is made by the organs, right? By the plants. So, this question should come in your head any single time, sir. Why is glucose getting dissolved in water? Because water is a universal solvent. Now, there are a lot of question marks that can be there in your head, guys. But like I said, it's just a 1 hour session. I have told you a topic which is starting from class 8 to class 12. So you do understand how vast is this topic. But what I have right now given you is a lot of things to search about, a lot of things to make your research in. Starting from why water is doing like that. What is so special? How is it being able to do it? Whether other solvents are not being able to do it, but how is water being able to do it? Isn't it a very good question, guys, that we can search about right after the session is over? Or let's say we have a time in our hand, 5 minutes or so, that we can search about this question. Right? Second thing is, Anishka, we can definitely take our time out to search about what is organic substance. What are the inorganic substances? Are they really the things that I told you right now in the session? I have told you the first definition and the second definition of organic and inorganic substances. But guys, this is 21st century. The things have changed hugely fast. So we have a lot of new, visible outcome for that. But guys, time is strained for us, so I cannot really tell you the entire topic. But I have given you the things to search about. So if we have some doubts right now, guys, I have a little bit of time in my hand, like 3 minutes or so, which I can devote for you. So, Tika, yes, Tavish, go on.
Sir, so will that lava lamp go on forever?
All right, this is a good question. I'm gonna answer your question with another question. It is like, do you really think two substances, when they are reacting with each other, would they react forever?
No, sir.
When would they stop reacting? The moment their energies are down, they do not have much energies to carry on anymore. So guys, the molecules, they do also have some within energy, internal energy. The moment that internal energy is done, if I show you the lava lamp, it has been settled down by now. It's not gonna go forever. All right. The moment the entire reaction is over, the lava lamp is gonna stop. Right. So it will last till CO2 escapes. Exactly about that. Yes, Diti, you have a question for me?
Sir, I have two questions. First question is, does it matter if we put the oil first or the baking soda first?
Doesn't really matter here. Because they're never gonna get dissolved, right?
Yeah.
No issues.
And sir, why does baking powder, why can't we use baking powder instead of baking soda?
That question. Because see, in baking powder, we have the acids already within it, right?
Yes.
So actually, what actually happens is baking powder is actually a little bit of this reaction is actually baking powder is reacting with an acid only. Baking soda is reacting with an acid only.
Yes, sir.
If you have the inbuilt acid now, you won't be able to control the reaction. The reaction will start right away. The moment you put the oil on it, the reaction will start right away. Can't really control it because the acid is there within it, which is tartaric acid. right?
Okay, sir. Thank you.
Sir,
And Mhm. Go on.
what will happen if baking soda and baking powder are put it together in the solution?
I have never done that. Definitely, you're not gonna see a blast happening. You're gonna be safe, but I don't really know what's gonna happen. It's like, it's like, so what would happen if I drink some milk with some sort of water on it? It's just an impurity here, so it's gonna decrease the reactivity a little bit. The carbon dioxide would come out, but pure form. It's the reagents are not there in their pure form, so you would be able to see it. It's not like the reaction won't happen. It would be happening. No such visible changes that you would be able to see for that. All right.
Okay, sir.
Yes, and your name I try to spell a lot of times in the class. Sri Vishwa, right?
Yes, sir.
Okay, I got it right. Now go on.
Yes, sir. So you can call me Vishwa as well. That's much easier.
All right, Vishwa.
Yes.
So
And so I just have one doubt. Is it possible that we can make hydrocarbons in lab?
yes, definitely. We
Okay,
have
then
made.
why not petroleum then? Because we are facing shortage of it, and then why not? Because you have explained us what is that carbon, how much are there, right? So why not we make a reaction in which we have that particular amount of carbon that is required? So we have a sustainable product, you can say.
I
This
can
is
see
just
an
a thought.
entrepreneur right now. Vishwa, the point is, you can make it, but it would cost more than whatever is present in, right?
Okay, so
Isn't it? In
it's
the end, you need
expensive.
the money.
Okay. Okay.
And you know what? We have a better substitute right now. Water is the
Yes.
best
We
fuel
can
out there,
split
isn't it?
we can split
Hydrogen and
water into
oxygen.
hydrogen and oxygen.
Hydrogen is the best fuel out there. The calorific value for hydrogen is 150. And the petrol and diesel that we use, the calorific
Yes.
value is 55. 100 more than 100 less than water, hydrogen. So guys, if we use hydrogen as a fuel, that can just completely demolish the entire
But
process.
hydrogen is very dangerous.
explosive, right?
It's flammable.
It's like when you would be putting hydrogen in your in your vehicle, you would be a ghost rider. That'd be all fired up, and you'd be riding your bike with a fire.
Sir, but then I've just read the news that Indian government is going to introduce hydrogen powered trains by the end of this year, hopefully. And that's
Let's
going
see
to be
if
a
they can store the
breakthrough.
hydrogen, then definitely they can use the hydrogen.
Yeah.
That's the best thing they can come up with. All right, Mahi, go on.
Yes, sir. Sir, in the reaction you showed us, there were red bubbles coming up too. So was that vinegar along with carbon dioxide?
Exactly, dear. I just gave it some sort of color, right? So the carbon dioxide is something that's coming out, not vinegar, only carbon dioxide. But as I have given some red color on it, that's why the carbon dioxide is red in, like the bubbles are a little bit red in color.
So it's only carbon dioxide. The vinegar has settled up.
Exactly.
Okay.
You're welcome. Shweta? Can't really hear you, dear. Could you just write it down? In the meantime, Prashi, you can move on.
Yes, sir. As paints or pigments are an inorganic substance, and vinegar is organic substance. So how did they get mixed together?
Which one?
Vinegar and pigment or paint.
Pigment or?
Paints. The red
Paints.
color paint you use, yes, sir.
Oh, that is okay. The pigments that I use and that with the vinegar. See,
Yes, sir.
vinegar over here, this is an organic substance. But what actually happens is it's a polar organic substance. Means, so actually, Prachi, no one is completely good in this world and no one is completely bad in this world, right? Similarly, some organic substances, they show some sort of inorganic nature as well. So this is an organic substance, but this carboxylic, this vinegar, it breaks. This was CH3COOH, right? This is how it looks, but it breaks into CH3 minus and H plus, and this ionic nature of it allows it to dissolve with water-like substances or the paint that I have mixed, that like substances, like a little bit of inorganic character it generates inside. I appreciate the question that you asked. It's a really nice question. So this
Thank you, sir.
actually it's an organic substance, but guys, a little bit of ionic character is present in there. Because of that, vinegar is also dissolving in water, although it's an inorganic solute. You do understand how vast is the topic we are talking about, isn't it? Okay. Yes, Rishik, be quick, but I am a little late now.
Sir, first you have to put baking soda, then oil or vinegar.
Doesn't matter. They're never gonna get mixed together. You can put it in any order you want. Yes, guys, I do know that you have a class. I have a class as well. So I have to leave now. I'll be coming back and answering all the other questions that you have, guys.
don't have a class now.
Not all of you, dear.
Ramesh,
Some
there
of
is
you
hand
have.
up.
That's
Some of you
fine.
have
Ramesh.
I
the
also
coding
don't
classes
have.
and all, right? All right, guys. That would be it then. Bye, everyone. Good
Bye,
night.
sir.
Bye,
Thank
sir.
Thank you.
you.
Good time.
Bye,
Bye,
sir.
sir.
Bye, sir. Thank you, sir.
Thank you,
Bye,
sir.
guys.
Bye,
Bye,
sir.
guys.
Thank
See
you,
you.
sir.
See you. Bye.